Sweet. Alright, hey guys, let's get started. Here's my link if you guys would like to follow along on my slides. That is a 0 and a capital L, case sensitive. I'll be having demos and stuff, so if you guys want to pull them up, let me know if you guys are ready. All right. Just a little bit about me. My name is Josh Robertson. I interned at Domo over the last summer for 3 months. I was on the web team, team of 6, and I was working on an internal product, and they just barely pushed the new site live. I was briefly working on it, and so that was a little bit about me, of my experience with JavaScript and that. I'm an open source enthusiast. I haven't contributed much, but I love open source, use it always. Even this presentation is with open source, Reveal.js. And just a little bit of background also, Snowflake that's what I named it, was one of my first Canvas experiments. And I was interested in Canvas because I saw I really liked animation, and I saw like you could easily do all this with the API. I forked some guy's code and made it, I guess you could say, better. I used Lodash and for the bouncer and made it so I can automatically, it goes to the full screen, and so when you resize it, it'll not break your machine. And this was a lot of fun. Made random ball sizes, random color. This one was one of my one of the funnest. And CodePen. I'll be using all my demos on CodePen just because it's easiest for me because it gives back data, and it's all your codes in one spot, I guess. And it's public, just like JSBin. I also like CodePen. I was surprised one day I got featured on the front page and got picked. It just was like a 2-hour project. I was just learning about the homothetic center, that's what it's called. It's a mathematical term. And I guess they somehow found it and liked it, and so I decided just to post that there. What I'll be covering is, I'll briefly talk about the drawing API for if you don't know about Canvas. I'll talk about basic trigonometry so we can do some animation because we use math. And the fun part is motion. I'll be talking about motion, velocity, and acceleration. So how many of you guys have used Canvas quite a bit, or at least know it? Cool. So I'll cover the API then, at least. Just to say what Canvas is, it's like graphics with JavaScript, so you can draw, and it's like an easy and powerful way to draw graphics with JavaScript. And you can use context, which is part of the API, which you can have JS issue it commands to draw anything you like. Just a forewarning, I do have lots of demos. I'll be showing a lot of code because I think Canvas is fun to actually work with it and see it in action. The drawing API. These are the main ones that we'll be using, and the basic ones that it's pretty self-explanatory. Stroke style changes the color of lines. Fill style changes the color of the fill, I guess, so if you have a circle inside of it. Line width, just the width of the line. They're pretty explanatory. Begin path, so when you draw, say you're drawing a square or multiple things, you have to begin the path and then close it. Well, you don't have to close it, but you stroke it so that you can have a new one. So you can have one object here, one there, and then you can do that. And then close path, so say if you have just some crazy lines everywhere and you don't know where the beginning is, you just can close it. Line 2, or stroke, you always just draw it, that just draws it. Line 2, so you give it an X and Y, so if you want to draw from the middle to 0, 0, then you can just, line 2, you give it X and Y, so you could just go to the middle. Or if you don't want to start from 0, 0, you can move to, which is basically like really drawing on a pad. You just pick up your pencil and put it somewhere, and then you can draw. Arc is what I use for drawing circles, and I think most people do. I'm not there's some other ways, but Arc is you give it an x, y, radius, start angle, so usually 0, but you can change it up. And the end angle, which we'll talk about in a little bit. Clear rect is clearing the canvas, which I'll also talk about a little bit later, more in depth. It's pretty simple. Fill rect is you can like draw rectangles, squares, and save and restore if you aren't using like objects or something to contain it. You can save it, which is basically like save it for later, and then restore if you want it back. So like different colors and stuff. So
is the save and restore on the canvas, or is that on the settings for the canvas?
So it's on, I think, the settings. If anyone else correct me wrong, or context, is it context? Oh yeah, ctx.save, that's the function, and then ctx.restore. You're right. Thanks. So how do we get the API? This is the, if you can't see it, it's you get name of a variable, most likely canvas. It doesn't have to be document.element by ID, but get element by ID. But if you have multiple canvases, then getting the element by ID is easier. So if you have two, like I had a static one and then a dynamic one, and then to do that, you just do get the context, and that's how you get the API. So clearing the canvas, it's like you clear it dry, and the 0, canvas width, canvas height is just the whole canvas, but you could do like a corner of it, but clearing it makes it so that you can animate things so it actually moves instead of just leaving like a trail, or it's like stop motion, how you take a picture, stop, take a picture. So if you don't want the pixels left over from previous frames. All right, enough of the API, let's talk about trigonometry. So math is not equal fear. People say, I'm not good at numbers, and math.sine and math.cosine scare me. Well, you hardly really deal with numbers. You're more visualizing shapes and relationships with it. You deal with positions, distances, and angles, and you never see the actual numbers. 90% of the trig you need is math sine and math cosine. So we'll talk about math sine and math cosine when we get to more of the code. So radians and degrees. This is, computers use radians. We think in like degrees, but computers use radians. So that 1 radian is kind of weird number. I thought that at first too. But when you have pi, which is 3.14, 2 pi equals 360 degrees, and 2 pi also equals 6.28 radians. So it ends up working out perfectly with that number. So radian is perfect. But if you could tell, pi radians equals half a circle, pi divided by 2 radians equals a fourth of a circle, and then 2 pi equals a circle. So if you're still thinking in degrees, then you can use these formulas. So if radians equal degrees, you can name a variable, so var degrees is equal to 180. You plug in degrees for that, and then you times it by math.pi divided by 180, and then you give in the radians. So for arc, the angle, you give it radians instead of degrees. And if you can also do the degrees formula. So how do we get a half circle of the radians? So first we tap into the API. You do this with all canvas. And then you give it a radius, so 50. I gave it a variable so you could tell it's not just some arbitrary number. So var radius equals 50. You begin the path, and you do arc. So I did canvas.width divided by 2 and canvas.height divided by 2, so it'll just be in the center of the page. So if you actually click on the example, it'll just be in the center of the page. And then radius, so 50. Start angle 0. So it'll start right here on the right, like on my diagram I showed you. And then I give it math.pi for the end angle, which is half a circle, like I showed you. And then CTX stroke, so you draw it. The same with a full circle, you just multiply it by 2, and that's a full circle. A fourth of a circle is you divide it by 2, same, different, but you notice how the circle's going down. You can tell it with the fourth circle and not 180, but you can tell it's going down, which I'll talk about in just a little bit. So let's do it with degrees, because you're not really comfortable with pi and radians. We can use my formula that I gave you. So var degrees equals 180, which is half a circle. Var radians equals degrees times math.pi divided by 180. And then when you actually plug in the end angle, you plug in radians. So pretty simple. Full circle, 360 degrees. Fourth circle, 90 degrees. And the same code.
Radius is just pixels.
Yeah. 50. Okay, so we talk about the classic coordinate system. In math, since I'm going to high school right now, I always jump back from the canvas coordinate system, which is pretty much the graphics coordinate system, because the computer goes from top left. So this is the classic one, but this is the one that we actually use for canvas. Positive goes down, positive goes right. Before it would be negative. So I was pretty confused at first. I was like, why are my things off my screen? But it's because positive goes down. But it's also backwards with the angle system. So positive goes up and negative goes down. Well, for canvas, it's actually opposite. Negative goes up, positive goes down, which makes sense for why my circles were going that way, so fourth is going that way. So now let's talk about sine waves. You can see how, and the radians is the top chart, and the degrees is on the bottom. You can see how pi is half a circle, and 180, of course, is half a circle. So if you, how the sine function behaves depending on the values you feed into it. So I made a little example, if I could get my mouse, that will show you just, if you could see that in the code. Here's just the main code right here for the actual sine wave. I begin the path. I move it to xy, which x is 0, so it'd be right in 0. Y center y, so down. Sorry. Okay. So I draw the path, or a begin path, then we move it to, so pick up the pencil, put it right where it starts. And I'll increment the x by speed x, so how fast it wants to go that way. And the angle, how fast it goes up and down, because the angle 0 is just the start of the circle, which I showed you from the chart. And then the y equals center y, so I want the start of the sine, actual math.sine, to start in the center, just where, it's where my y is. So if my y was different, I just do math.sine. I give it the angle and multiply by range, so if I change the range, then it would go less or higher, which I can just show you, just simple. And then the other ones are just so it gives it the frame, which aren't as important. Alright, so this is kind of boring. And let's animate with sine waves. So we clear the canvas so it doesn't leave its trail. And now we animate. We get a request animation frame, of course, because we need a loop, so we need it to always refresh, just like a game loop. We create the circle or whatever you want to create, give it an x and y, and let's loop it so that when it gets off the screen, it'll just send in another ball and another ball. And random size, sure, why not? So here's this other example that I created. So once it gets off the screen, we'll send in another one. I made the canvas a little too big. I could have done full. And this is basically the same. The only thing that's different is instead I'm giving it a ball or an object so that I can use a for loop and array to push it. So right here I'm pushing a new ball so I could get this ball. So it's object so it can save the state. This is an ugly way to do it because I'm doing a set timeout, but I just wanted to show you that they can keep coming and animating. So I have my game loop, request animation. I do angle increment with the speed y equal to. I do the same as y equals so that it'll go the same way, and how much range is the 100, however deep I want to. And the only reason I'm doing a for loop is so that I have a variable up here called balls, so 25. And I just get the length of it, so I send in 25 balls, or technically 24. And then I just paint them. So I give it CTX radius. And it's just I also made a random, if you're wondering about the get random number, it's just so every time you refresh it, I just get a random ball size. And that's animating with sine waves. Yeah, no problem. Sorry. I didn't mean to cancel it or close it.
So I clocked out for a second when you were talking about the request animation frame.
Oh, okay.
That's something that I've heard a lot about and been curious. So you have this set timeout for every...
Well, the set timeout is kind of a ghetto way to do it, to be honest. It's just so that every 5,200 milliseconds, it'll send in a new ball.
Okay, so that...
But the real thing is request animation frame. If I didn't have set timeout, it'd only send one ball. And if the request animation frame is like a game loop where it's always refreshing because it calls itself right here, right? If you couldn't see it.
How often does that get called?
I don't know the exact, but I know that if you, does anyone else know how often it gets called?
It tries to get at least 60 frames a second.
60 frames, yeah, that's true. So.
It also passes in a parameter, which is like a really accurate timestamp. So that way, if your animations are based off of time, it can actually, you can use that really accurate timestamp to change your animations accordingly if you're lagging more than 60 frames per second or if it's going faster than that, something like that.
So basically, if my browser is capable of doing 60 frames or better, it's going to shoot for 60 frames. And it's not capable of doing 60 frames or better, I use the timer to let my program
Well,
know to change.
no, the timer's just to, sorry, the timer's just to send in a new ball every.
You're most likely not going to be able to actually animate anything faster than you can with request animation frame. In fact, when it comes to animations, using request animation frame is by far and away the best method to do it with. Otherwise, you're going to be trying to animate things, and the browser's not going to be able to render them accurately or in time, so you'll get all sorts of jankiness.
What it does is it queues it up for the next ping.
And it actually will affect the event loop, so it will get a frame that is literally only for paint, and it will not run your event loop code, so it will prevent your code from causing jank in your paint. Is the magic sauce of it is it actually ties in really deeply with the event loop and keeps actual execution code from happening in that frame. So it gives you a frame that will only be used for painting and reflow.
Does that answer your question?
Yeah.
Okay, cool. We'll move on then. Or who else is? Okay. All right, enough of sine waves. Let's talk about some motion, the fun part. I'll just talk about velocity. So velocity, in its basic term, is something that moves, but it's actually speed and direction. It needs a direction to go. So velocity on x equals horizontal movement, so it's moving horizontally, and then velocity on y equals vertical movement. I bolded the v and x and v and y because people, when they're writing code, they write .vx or .vy, so they use those. And I didn't really know what it meant until I finally started reading about Canvas, and that's what it actually means, if you're wondering. Just to show you, actually you probably can't see that, but it just says Vx and Vy if you have my slides pulled up. So I made just a little demo on velocity on x-axis, pretty simple. Doesn't require much code, but that's just velocity. It has an x, and then you increment it by velocity. And the only reason it seems kind of complex is because I just have it come back to 0, which is why I minus the rectangle width, so when it gets across the screen, it'll just come over, which is also my boundary right here. But you're just incrementing by velocity, with the number basically, by Vx. Any questions on that? Okay.
So first, you're going to laugh your way through AP physics if you're not already thinking. The whole thing has been bore you to tears. It's literally velocity and acceleration.
Okay, so velocity on both axes. This is what it'd be on both axes. And as far as I know, I don't know how to calculate the angle. So I'll be talking about angular velocity just right after this. This is just the same. I just get a Vy, y, incremented both by the appropriate value, I guess, if you'd like. And then I just have it boundary, so it'd come back to 0, 0. So that's velocity.
Where are you setting your center?
Let me see. Where? This? Oh, I just go on 0, 0, so top. I don't have a. Oh, what do you mean?
Of the circle, is the base of the circle at the top left of the circle, or is it in the center of the circle?
Center of the circle.
Which, if you notice, that's why the top right corner or bottom right corner appears in the frame, is because it's the center of the circle
Yeah.
at the bottom right.
Which, yeah, I could have minused it, but I just thought it would be fine either way. So angular velocity, say we want to get a 45-degree object going 45 degrees or 90 degrees, or just a specific degree. So we kind of cheated with velocity because we have 2 different speeds and 2 different directions. So what if you have like a value for speed and angle for direction, which is what I'm talking about right here. There isn't really a Vx or Vy or anything similar to that definition. So we get back to math. We use a formula if you want to go 45 degrees. So we say var angle. I don't have it on there, but the angle that I'm getting right there, I could just say whatever angle. So var angle equals 90, 45, whatever angle. So I can convert it to radians because I don't know what 35 or whatever is in radians, 32.5. And so I use my formula. And then I get my Vx and Vy. So Vx equals math.cos. And then you plug in radians because the computer thinks in radians. And you times it by the speed. The reason why I use cos on Vx, cosine, is because I didn't talk about it, but sine is opposite over hypotenuse, and cosine is adjacent over hypotenuse. And right at the top, so the horizontal, right above 45 degrees, is my Vx. So I need my adjacent, which if we have the angle and the hypotenuse or any side, then we can figure out all the others. So I have 45 degrees. So I use cosine, which is adjacent, so adjacent to that, which would be the Vx, over the hypotenuse, which is 1 pixel, which will get me my Vx speed. And then for Vy, I just use sine because opposite over hypotenuse. So I get my leg, my Vy leg, which is vertical movement. And that's why I use sine for Vy. And I made a little demo. I use this ruler. It says, if you can't see, it says negative 45, the angle, because like I was saying, the angle system is messed up from I guess, I don't know what else uses negative going down, but Canvas does. And so I just had to put negative 45, where 45 would be going up. But that's 45 degrees. If I'd actually put it up, then you would see that it is 45. And for my example, I just made a little demo, so you could see that's 45 degrees. And if you don't believe me, I could change this right here, angle, to 90, and we all know that 90 degrees is up and down, so like that. You can see that it goes right there. That took a while, by the way, just so you can see that. Pretty impressive. I made that by hand. And I have some notes, cosine adjacent over hypotenuse, opposite over hypotenuse, and then I convert the degrees to radians. And of course, and then I have them like in all my demos. The if is just so I could set it back to 0 so you could continue seeing it. But it's the same. I just increment the x by Vx, y by Vy. I clear the canvas, of course, request animation frame. And then these 2 are just so I could get my ball. I didn't have to do that, but I like working with objects and such. All right. So now I think we have a good grasp of velocity. Is there any questions for velocity? Okay. So now we'll talk about acceleration. So it is common to think of like acceleration as speeding up and slowing down. Acceleration is described like as a value in a direction, but velocity changes the position of an object. So I have this circle going this way, or going that way. It doesn't matter. I just didn't want to say it weird for the people listening later. I'm moving an object, the x and y. So I have an x and y. Velocity moves the object, but I want to increment the velocity with the acceleration. So I have 3 different variables. One, I have an x, and I have Vx incrementing the x. Then I have an acceleration that accelerates the Vx. So now I have 3 different levels. And so now, that's what acceleration is. So I made up a little example. Acceleration on x-axis. I just set the x and Vx to 0 to be simple. So I just have a request animation frame. The x, you can see, is incremented by the Vx. And the Vx is incremented by the acceleration, ax, ay, acceleration on x, acceleration on y. So I loop it so you guys can see that it actually does get quicker. It accelerates. Yeah. So, and that'll go on for a while. And then I have acceleration on y-axis, which is the exact same, just change variables, and it goes up, through, down, accelerates. So now we have acceleration and velocity. Let's combine them together and use both axes together. So both the acceleration axes and both velocity axes. So if you guys are pulled up on my slides, if you want to click on this, I use my arrows to control it. So up, I go, it just keeps going, down, left, right. And you can go off the screen because I like having it come around because it's fun to mess around with. So now I'll show you the code. I just set it all to 0, so it'll just be stationary when you get there in the center of the page. I get my center x, center y, which is the canvas width divided by 2, canvas height divided by 2, and my reactiveness, which 0.1 I felt like was one of the probably the best numbers for it. So I do my objects again. I like to do those, and my switch statement. So I add an event listener, key down. So I have 37. Case 37 and case 38. So say I go up on the arrow, then I'm going to want to add reactiveness, which is 0.1 to AX, which is the acceleration on X, which I'll increment to the velocity on X. And then it's just opposite. So if I go down, I minus it. And then if I go left, I'll minus it, and right, I'll add it. And then the thing is it'll just keep accelerating, but I don't want that. You want to, once you let go of the key, set it to 0, the acceleration, not the velocity. If I set the velocity to 0, then it'll just stop moving. But if I set the acceleration to 0, then it'll just continue moving at a constant speed. I guess you could change it so it'd be slowly decreased speed, but I just have it constant. So that's been going the same speed since the last time I touched it. And then I have my request animation frame, which is the loop. I clear the canvas so you don't have a trail, which having a trail is kind of cool, but only on some things. I make a new ball, and then my boundary logic, it's pretty simple from there. And then I just do the same, x increments with vx, y increments with vy, and then do the same for acceleration with velocity. And so you get your velocity and acceleration, which if you want to add stuff, you could add gravity, boundary, so instead of looping it, you'd have it like bounce around. I've had tons of demos, so I have a bouncing ball, if you guys want to check my page out. So, thank you. That's my presentation about Canvas. Is there any questions, or?
How do you get to be so freaking awesome?
Friends, Merritt Christensen told me I worked at Domo. Learn on my own, I guess. Looking up things. A lot of books, actually. I've read like 4 Canvas books. So it's a lot of fun to me.